Okay, good evening. Welcome to Math for Kids number 68. Today we're going to continue off of something we were talking about yesterday. Yesterday in Family Math 3 we talked about countable infinity. And we learned that there are the same number of counting numbers. Boy, this board really needs to get clean, doesn't it? As there are even numbers. And both of them, and the number for both of them, which one of these has more in the list when you go all the way out to infinity? They're the same. So that was pretty surprising, and if you want to learn about that, you can watch Family Math number 3. Today we're going to learn about something even more crazy. Where did that eraser go? Oh,
not countable infinity?
No, we're going to learn that a really neat thing that says that these numbers, the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way out to infinity, is the same number as all of the fractions. Same infinity as all fractions.
Cool.
Okay, now, do you know what fractions are? A little bit? Here, stand over here. Do you know what fractions are?
Yeah, they're like numbers that you put a slash in between.
Right, like 1/2. And give me an example. You give me an example of a fraction.
Yeah, like 1/9.
1/9. Okay, write it. Right on the board. Write 1/9. 9th. Okay. You give me a crazy fraction.
How about 30 over 2001?
30 over 2001. That's a perfectly good fraction. Is that fraction in reduced form, by the way? What do you think?
Well, it's interesting.
That is a very interesting question. Let's not spend like 8 years thinking about it. Let's see. Are there any numbers that divide into the top that divide into the bottom, just as an aside?
3.
How do you know?
Some of the digits.
Right, we know, well, you don't have to do anything. We know 3 goes into 30 because it's just 3 times 10, but we also know 3 goes into 2001 because 2 plus 0 plus 0 plus 1 is 3. Anyway, that's a different story for a different time.
Yeah.
So a fraction is any number equals a over b, and for today we're just going to worry about positive fractions where b is not equal to 0, and we'll say a is not equal to 0 just for fun. Okay, so any positive two counting numbers divided by. So just like you said, we could have 1/9, or we could have 30 over 2001. Now here's the strange thing. A fraction like 10 over 4 is the same number as 5 over 2. Right?
Yeah, you can learn about that on Khan Academy.
Yeah, you can learn about that on Khan Academy. So what we're going to do, and this is really neat. Remember, in order to show that something has the two infinities are the same, we have to count the fractions. So we have to figure out how to count the fractions. And we're going to do it in a really clever way that I think was invented by Cantor, this mathematician named Cantor, but I'm not 100% sure. So first thing we're going to do is we're going to make a big grid that goes to infinity in this direction and infinity in that direction. Can you go check that this is still on the camera for me? Then we're going to write the numbers, counting numbers.
Yeah, that's on camera.
Great. Make this big grid. Make a 9 up here. And for any point that's on both of our grids, we're going to make a fraction. So, for example, let me just draw a few of the points. Okay. So this is the number. It has a 2 here and a 5 here. So we're going to call this dot, we're going to say this is, just for fun, we're going to say this is the fraction 2 over 5.
2/5.
2/5, okay? And just for fun, we're going to say that this dot over here, which maybe has an 8 and a 3, call it, it's an 8 and a 3. What fraction is this going to be, just for fun?
8/3.
8/3. Okay? Do you understand this?
Yeah.
Okay. I'll give you a dot test. You ready for a dot test? So this is the fraction that has a 5 and an 8.
It's going to be 5/8.
It's 5/8. Very good. Okay. So let me fill in some dots here, and then we're going to do something really, really amazing. Okay, because we have all of these fractions, and some of them are the same, right? So this fraction, for example, 2/4, which we're going to say is 2/4, well, that's the same as what fraction?
Half.
1/2. That's the same as this fraction, 1/2. But we're going to count them as being different. So if anything, here, even sometimes we're counting fractions that are the same twice. So we would even be counting more than all the fractions, right? Okay. All right, so let's look at and see what we're going to do here. It's hard to figure out how we're going to count all these fractions.
You can't count to infinity.
You can't count to infinity, but what we want to do is we want to be able to say one of these fractions is 1, is the first fraction. Another one is the second fraction. Another is the third fraction. But if we start doing that, like in a really simple way, we end up going all the way out to infinity. Like if we said this is the first one, second one, third one, fourth one, fifth one, sixth one, seventh one, eighth one, ninth one, we'd get all the way out to infinity, and we never count any of the ones up here, right?
Mm-hmm. Yeah.
Same thing if we started going straight up. We would say 1, 2, 3, 4, 5, 6, 7, 8, 9, and we would get all the way up to infinity. And we would never count the ones that were over here. But Cantor figured out this amazing thing. He's going to start, oh actually let me do a different color marker. Let me pick this black one. Okay, he's going to start here, and this is 1, 1, right? So this is the fraction 1/1, which equals
1.
1. And then he's going to go up here, and then down, over, up diagonally, up, diagonal, over, up diagonal, whoops,
Whoopsie.
up diagonal, up, then down diagonal, across, up diagonal. Now look what happens. He hits every single number with the zigzag. So he just keeps zigging and zagging. And then you would go here like this, and then over, and then down, and then over and up. So he just keeps zigzagging back and forth.
And it keeps getting bigger and bigger.
It keeps getting bigger and bigger and bigger. But you know what? It hits all of the numbers.
Which is a good thing.
And these numbers represent all of the fractions. And so you know what that means?
What?
It means we can count the fractions. We can say there's a first one, a second one, a third one, a fourth one, a fifth one. Now it doesn't really make a whole lot of sense to say that this dot up here is like the, you know, the 93rd fraction. But it doesn't matter if it makes sense or not, just as long as we figured out how to count them. And so you walk along this really crazy, looping, jaggedy line,
Yeah.
and you hit all of the fractions. And that tells you that there are the same number of fractions as there are integers, or as there are counting numbers. And you know why this is really surprising?
What?
Let me show you. If we look on a number line, we have 0, 1, 2, actually let me make it a little bigger than this.
I'll go up to infinity.
No, I'm not going to go all the way to infinity. We'll go 0, 1, 2, 3, and then my number line can go on for a long time. But here's some fractions. Ready? 1/2, 1/3, 2/3, 1/4,
3/4.
3/4. Now we have 2/4 here. Then 1/5, 2/5, 3/5, 4/5. And you start writing all your fractions, your 6ths and your 7ths and your 8ths and your 9ths.
And your infinity is
And it looks like
peach fuzz.
when I get to 1/1,000,000, I'm going to fill in all these numbers in here. And it looks like I filled in just about everything. And then when I get over here between 1 and 2, I can do the same thing, because I can have 3/2, 5/4, 7/4. Remember, I got these, and then like when I get up to 1,000,000, the millions over here, I'm going to have all this filled in over here. So it looks like there's way more fractions than there are 1, 2, 3. Because it looks like I've got everything filled in. Everything. Like, how did I miss anything? But it's the same number. Isn't that amazing?
That is totally amazing.
So when people discovered this, they were stunned. Nobody thought that you could have the same number. Fractions are called something, they're called rational numbers.
Yeah.
Okay? So nobody thought you could have the same number of rational numbers as you have integers. And people were blown away. Isn't that neat?
Awesome.
Yeah?
Yeah,
Yeah.
it's really awesome.
That's really fun.
Awesome.
Alright, good job, Snake. Guys.
Awesome.